Hi, and welcome to my channel Technomora. Today's video is all about an iconic 70s tuner amplifier of the brand Saba, and more specifically the model Studio 8070. So, grab your favorite drink and snack, sit back and enjoy. So, the seller was rather sparse with the information he could give me about this tuner amplifier. In fact, the two things he told me was that the amplifier doesn't seem to work. It only gives out a sort of a humming or buzzing noise from the speakers, and the needle for the tuning doesn't want to move when you rotate the tuning knob, and indeed it doesn't, or maybe a tiny little bit, but it really seems stuck. So there's not too much information to go about this amplifier, tuner amplifier, but I'd love to restore this one because ticks all my boxes. I love everything which is vintage 70s space age stuff, and this model particularly is really right up my alley. So yeah, I'm going to disassemble it first, because as it is right now it's rather large on my small workbench. And then we're going to have a closer look at the electronics and obviously also the mechanics, since the mechanical dial doesn't seem to work very well. So to disassemble the case of the tuner amplifier of the Saba, I need to do two things first. I need to take off the bottom plate, which is some kind of masonite, and I need to take off all the buttons at the top. Well, at least the slider buttons on the left and the tuner button on the right. Alright, I extracted all the screws. You need to extract 5 screws really, so 2 on this side, 2 on the other side, and then 1 in the center. Now, and they are peculiar screws. I would say brass, quite long. I would say roughly 2 inches or 5 centimeters long. The washers are brass as well. Now, judging by their state, I would hazard that this tuner has been opened before. But right away I hit a snag, and the screw down here inside the tuner is just turning crazy. I just can't undo the screw. It seems to just turn and turn and turn without releasing the bolt or whatever inside the case. So obviously I don't want to damage the case more than necessary, so I'll need a moment longer to undo this particular screw right here. Alright, unfortunately I had to resort to a controlled break, because if I was going to open it up somehow, yeah, I was afraid of damaging the outer case, so I resorted to, yeah, let's say a minimum of force to release the last screw that was holding down the top of the case. And the reason why I couldn't unscrew this last one is because it was completely stuck into this little nut here. Yeah, you can see the white residue where it was oxidized. You know, obviously this is brass, so it won't rust, but it will oxidize, and due to the oxidization it was stuck into this little lock nut, and this nut was in turn stuck into this plastic brace here, and as you can tell it's broken now, but I can fix that with epoxy. And this is one of the parts where that little lock nut was inserted. So it was like a press fit. So this is a view from the rear inside the tuner amplifier. Now there's one very interesting detail about it. If you have a closer look at this part right here, you'll notice that it says quadraphonic. So this amplifier was meant to be used in a quadraphonic installation, right, with two pairs of speakers, which is very interesting. I think quadraphonic stereo, you could say, was something that they tried to launch in the 70s, but it never took hold really, because, well, it was complicated. It was a complicated system, and well, obviously it cost more, you know, because every quadraphonic installation required 4 speakers instead of 2. Interesting. That is a detail I wasn't aware of when I bought this tuner amplifier. It is something, however, I noticed while reading the service manual, although they make very little mention of this quadraphonic solution. Instead, they seem to describe it as double stereo. So you can either use speakers at the back of the room, so to speak, or at the front. But the quadraphonic definition is nowhere absolutely mentioned in the service manual. Either way, this is the inside of the tuner amplifier. Very dusty, very dirty. It will need some in-depth cleaning, you know. And over there is the tuning knob mechanism over there with a counterweight, which is also typical, something they did to give a nicer feeling while tuning. But yes, there's something obviously wrong with it, since I can't move the tuning needle, which is right now stuck in this position here. Also, remember the 2 burn spots in the top of the case? Well, that would be obviously created by these 2 light bulbs here. Yeah, so those do release quite a bit of heat. I don't know if they work, but even if they work, I think I will replace them with LEDs. Just for the fact that light bulbs, I mean filament light bulbs, is so passé, you know. I prefer LEDs anyway. LEDs give a brighter light, less heat, and yeah, they are a little bit more modern. Anyway, this stage here of the tuner amplifier, this is actually the amplification part, yeah, or the amplifier if you wish. 2 heat sinks, a whole bunch of power transistors on the inside, a few large capacitors. I will probably replace all the electrolytic capacitors inside, because let's face it, this device is now over 50 years old, so I don't think the electrolytics are okay anymore. Also, it has a few of those infamous orange colored electrolytics. You see them, a few down there, and those were really not very good. So whenever I encountered those, I systematically replace them. There are a few more in the amplification section down there. Alright, so yeah, there's quite a bit to do inside. Well, first of all, cleaning, of course, and it's fed through a transformer, so it has a linear power supply, no switching power supply at all, which is good actually. I prefer that. Less hum and less interference with other devices in my home. So, and then on the left side we come to the high frequency part of the tuner, which as far as I remember is FM stereo, short wave, long wave and medium wave. Yeah. So there. That will also need a bit of cleaning. Also, you know, fixing that mechanical tuning part. But I think, except for maybe replacing a few electrolytics, this part of the amplifier, the tuner amplifying fire, should be okay. Alright, I gave the inside of the tuner amplifier, you know, the Saba, a cursory cleaning, not too intensive, just to allow me to work, let's say, a little bit more comfortably. Now, I decided that since I'm going to give the case or the cabinet of the Saba a cleaning, a thorough cleaning, the bottom part at least as well, I need to unmount the whole thing, and for that I need to do quite a number of screws. There are 3 here at the back that I need to undo, and then there are 2 screws down there I need to do. Like down there, you see one of them there, and the other one is just behind the pillar here, right there. See? That one there. And then I need to undo 2 more here, so one here and then one over there in the corner there. Okay, so yeah, I know it's a bit too dark, you can't see it, but trust me, it is there. Yeah, and then I need to disassemble, or rather release, the front panel from the case by releasing a screw here and another one there, right there. Okay, so yeah, quite a number of screws, but we're not done yet. Then I need to unmount or release, let's say, the transformer from the bottom of the cabinet, and I need also to release the 220, well, the AC cable from the rest of the assembly, and that means basically unsoldering it right there, down there on the on-off switch. You see the blue and the black wire. So there you are, 20 minutes later, a completely stripped naked Saba tuner amplifier. Unfortunately, it wasn't as simple as described in the service manual, because I had to not only disconnect the AC wires from the on-off switch down there to the front of the chassis, but I also had to disconnect one wire from the transformer and one yellow wire going to the same switch from the AC fuse, which the fuse holder is built into the bottom of the cabinet. So that was a moderately unpleasant little job to do. Okay, so there you go, a close-up from the front panel of the Saba. Once you've released the two little screws on either side of the panel, on the inside, the whole front panel slides out of the bottom case together with the main PCB. So you need to juggle a bit to get it all out in one go, because remember, you also need to get a good grip on a very hefty transformer. I mean, this transformer I think is close to 2 pounds of iron. Okay, so don't be mistaken, you'll need a good firm grip to keep this in your hands without dropping the whole PCB and the front plate. Okay, so actually, come to think of it, maybe it would be easier to leave the front plate screwed to the front plate of the chassis and only remove the screws after you're done. But yeah, well, it's up to you and how handy you are, but yeah, there you go. A last detail before we move on to the next job. I was right in the beginning to say that this tuner can handle FM, long wave, AM and shortwave. Okay, in German it's called Ultrakurzwelle, Lange Welle, Mittelwelle and Kurzwelle. Okay, so there you go. As you can tell, there's no mention on the front panel of quadrophonia, but you can see here two knobs to switch on either the front two stereo speakers or the back two stereo speakers. Okay, I'm guessing you can even switch them on together, even when there is no quadraphonic signal coming through. But I guess that's something we'll have to find out, right? Alright, one of the first and easiest things to do when you're starting to look for faults in a vintage device or in vintage equipment is to look for the obvious things, namely a blown fuse, or maybe a broken cable, you know, a broken AC cable or stuff like that. Yeah, I guess in certain economic terms they call it quick wins. So that's exactly what I'm going to do. I will first of all measure whether the AC cable is still good or not, and then see if the AC fuse and fuse holder are still okay. Alright, so I set my multimeter to short detection, you know, so when the probes are shorted it will beep. Okay, so let's measure the AC cable first. So if I touch both of the pins of the AC connector, it should not beep, and it doesn't, right? So now if I short the other end of the AC cable, you know, with with a crocodile clamp like this, alright, like that. Now when I measure, now when I measure between the two pins of the AC connector, now it should beep, and it does. So okay, the AC cable at first blush seems to be okay. So we can move on now to measuring the fuses of the tuner amplifier. And the first fuse to measure is the AC fuse right there. Okay, right there, which according to what's written on the chassis should be a 630 milliamps fuse. So let's see if it's still good. Well, it certainly sounds like it. Alright, now according to the schematic of the amplifier, there are several output voltages from the main power supply. Okay, and the voltage that goes directly to the amplifier section of the tuner amplifier is fed by a 46 volts unregulated DC voltage. The other voltages are used either in the preamp section or in the tuner section. Okay, so you see there are several DC voltages output. Now there's also an AC voltage being output, and that comes directly from the transformer. So here's the transformer, right? And here's the fuse that we just measured, remember? And it's quoted as being a 630. It's quoted as being a 630 milliamps fuse, you know, on the primary of the transformer. Now, there are several fuses in the power supply section. One is quoted at 1.25 amperes and is used to feed all the light bulbs inside the tuner amplifier, and the other fuses are all concentrated around the DC outputs, right? So you have, let's see, you have a DC output of 14.5 volts, yeah, which is protected by a 160 milliamps fuse. There is another section here, okay, which generates 20 volts DC, okay, so quoted as section plus 5, so the B plus voltage 5, and let me see, it's protected by a diode, fuse of 50 milliamps right here. Okay. There are more fuses, obviously. So those are only 3 fuses that are obvious. The other fuses are all located in the amplifier section. Let me show you. The amplifier section, oops, is here, I think. Yeah. So in the amplification section, which is right here, you see the 45 or 46 volts DC coming in. Let me see, is this the left or the right channel? Does it say? It's not immediately obvious. Either way, so let's say this is the left channel, so it is protected in turn by a 1.25 amps fuse, and so is the right channel, the right output channel, okay, which is protected by a 1.25 amps fuse, right? So yeah, the amplification is done by what some would call a quote-unquote classic push-pull circuit. Yeah, this is the end stage here, and the transistors around it are what are mainly described as the driver transistors and the constant current sources, yeah, which drive the end stage, which is apparently built up from a BC 238B and a BD 698. So these are both silicium transistors, and this is an NPN and this is a PNP. Okay, and you'll find the same thing on the other channel. So a push-pull configuration built out of an NPN and a PNP. Okay, with a few transistors and components around it to set, let's say, idle current and to bias them to the correct voltage, you know, so that they are responsive to the sound. We will probably have to have a look at these potentiometers you see here. I don't know if you guys can see that, but let's show it from a close-up. Okay, so right here you see this little pot here, and on the other channel you see a similar pot there. Yeah, with those trimmers, I should say, you can set the rest current or the idle current of the output stage, which is quite important if you want undistorted sound. Yeah, so setting those correctly are very important if you want qualitative outputs. Yeah, so an undistorted, noise-free sound. Alright, let's measure the fuses on the output stage of the Saba. So let's measure this channel first. Okay, that fuse sounds good, so let's measure it here. Okay, so the fuses going to the, or in the B plus circuit that feeds the amplifier channels, so the left and the right channels, are okay. So those are, according to the schematic, are rated to 1.25 amps. Alright, now let's move on to the fuses in the power supply. Let's see. Can you guys see it? Yeah, I think you can see it. Okay, so I don't know which is which exactly, but I mean, let's measure whether they are good or not at all. Okay, so let's measure this one first. Yep, that one is good. Next. Yep, that one is good too. That one is good too. Okay, so far so good. All the fuses we measured seem to be okay. The AC wire and plug and fuse are also okay. So what I need to do next is to switch the Saba on and then see if we get all the voltages, all the B plus voltages that are marked on the schematic. Alright, I'm going to measure a few voltages on the transformer, and I should measure at least 3 voltages, namely 6 to 7 volts AC, 16 to 17 volts AC, and then 34 volts AC. Okay, so let's measure the first voltage, namely the around 6 volts. So I don't know if can you guys see the multimeter? I think you can. There. Okay. So let's measure the 6 voltage, which is for the light bulbs. All right. Then measure the next voltage, which should be around 17 volts. Yep. 16, 17. That's for all the other devices on the tuner amplifier, you know. And then let's measure the 34 volts, which should be for the amplifier. There you go. So, as far as I can tell, the transformer works great. Alright, I took an executive decision in that I'm going to replace all the electrolytics on the main board first before I start looking for faults, possible faults on the main board. For 2 reasons mainly. First of all, I do intend to keep this tuner amplifier as a collection piece which I want to display in my living room. So I want it to work optimally. Second, in my experience, although not always, electrolytics are often the source of problems in electronic circuits. And since most, if not all, of these electrolytics are at least 50 years old, I think the best thing to do is to just replace them all the electrolytics, and be done with it, and then start checking the working of the main PCB, you know, and every separate part of the appliance. Now, there are also a few tantalum capacitors on the board, and I really don't like tantalum capacitors. They have the nasty habit of failing, and spectacularly failing. So most of them, if they fail, they burn and smoke and stink. And you could imagine that is probably not healthy, and well, presents a fire hazard. So yes, wherever I can, I'm going to replace the tantalum capacitors on the main board as well. I've decided to tackle the hardest board first, meaning that, you know, I want to replace the electrolytics. And the sound regulation board, which is this board here, which has the volume, the tone, and the pan potentiometers, which are slide potentiometers, as you can tell. And it turns out, to take it out, you need to release at least 2 screws. One in the top right corner over there, right over there, and one in the top left corner over here. Okay, and then you need to disconnect a few wires that go to the amplifier section. Alright, and those wires are colored. So there's a green wire here, a black one, and a red one. As far as I can tell, these 3 wires need to be disconnected, and possibly one of those yellow wires, I'm not certain. But at least those 3 wires need to be disconnected, and if that is done, then I can remove the board from its position, and that way I can work on it a bit more comfortably. By the way, removing or releasing these little wires that run to the sound module is relatively easy, simple. Each wire is terminated by a small spade connector, like that one over there, right? So all I need to do is to carefully pull it off the connector on the main board. And as I thought, this yellow wire here needs to be disconnected as well. Alright, I had a close look at the soundboard, and it has 4 tantalums that I want to replace, even though they look okay. Since I've got the board out anyway, I might just as well replace the tantalums, right? So there are 2 tantalums on the right side, those green ones there. Okay, and then there's another one there, and they are both rated for, let's have a look, 35 volts, let's see, 0.47 microfarad. Okay, notice that the anode of the tantalum is marked by a little plus symbol, right? So, and on the main board, well, on the PCB, it's marked as plus over there, right? So the 2 green ones are 0.47 microfarad, 35 volts. So I'm going to replace those with classical electrolytics, and then you have 2 red colored tantalums. You have one here which is rated at 4.7 microfarad, come on, 35 volts, right? And there's another one below that, right there, rated at the same value, so 4.7 microfarad, 35 volts. Alright, I just extracted this capacitor here from that location over there. Alright, right here. It's at measurement point H2, located there. Now, this capacitor, weirdly enough, is a 15 microfarad rated at 350 volts. I mean DC. Yeah. Now, when I have a look at the schematic of the Saba, you can in fact see the capacitor. It's this one. It's capacitor C1033. Yeah. And this one is connected via the circuitry to capacitor C1032, which in fact is the same type of capacitor. So a 15 microfarad, 350 volts. Now, why in Earth's name you would want to use such a high voltage in a transistor radio or tuner or amplifier is beyond me. Now, when I analyze the circuitry, so you know, it comes from one of the secondaries of the transformer. It goes through a high voltage rectifier diode, which is the BY127, and then at that particular measurement point it should give 200 volts. Now, logically, of course, if you're working with that kind of high voltage, you would use a capacitor which could handle it, you know, and therefore this one is rated at 350 volts. But, and of course then the next one is also rated at 350 volts. But if you follow the circuit to its logical end, yeah, it says it outputs 20 volts DC. Granted, there's a Zener diode here, which is rated, I think, at 33 volts. Okay, so honestly, the reason why they would do that is a bit beyond me. You know, these two high voltage capacitors are connected in what is called a pi filter. Yeah, so capacitor with a resistor and then another capacitor, which they often use to attenuate a lot of noise in a rectified DC current, right? And then they drop the voltage over a few resistors in series, which I imagine they would do to be able to drop enough heat, you know, and then they filter the voltage again, you know, like the schematic indicates. It drops after the first 10k to 120 volts, then it drops again and it's filtered again, yeah, which basically would constitute a sort of a, I would gather, a low pass filter, and combined with yeah, sort of low pass filter, and then it goes into a Zener diode, and then it's ultimately dropped to 33 volts, which in turn via a dropper resistance is dropped to 20 volts. Now, unless of course one of you watching this is an engineer and could explain to me what is the sense of doing this. I'd like to know, because I'm a little bit stumped right now. Either way, I'm going to replace the capacitors, obviously, with new capacitors rated for more or less the same type of voltage, you know. The cap itself is reasonably okay. Let me show you. So it's roughly 20% over value. It's not too lossy, and the ESR is average, let's say. It's a bit high for such a cap. So yeah, it's certainly not brand new anymore. So yes, I am going to replace it, but I have to be honest with you. Right now, I really don't know what the use of those caps could be, and why in Earth's name the Saba engineers decided they needed 200 volts over there, unless of course it's because the transformer delivers 200 volts at that secondary, and that was the type of transformers they had in the factory. And so then they said, well, sod it, we're going to use the transformers we have, and we're going to drop the voltage to what we really need. So that would be the only reason, in my opinion, why they would have made such a circuit. Alright, I took another executive decision. I decided that I would completely decouple the transformer from the main board, for the very simple reason that it's a real hassle to work on the main board with the transformer permanently attached. So I'm taking the easy route, which is that I cut the cables right at the transformer, yeah, and I leave little stubs in place, you know, such that when the moment comes that I need to reconnect everything, I only need to follow the color code, right? The cables are more than long enough once the transformer is mounted back, so it's not like I'm going to lose any appreciable length. You know, I'm not going to have to pull and stretch to get it reconnected. But in the end, you know, it's just safer. I mean, this transformer weighs close to 2 pounds, you know, and 2 pounds of iron balancing precariously while you're working on a main PCB is not ideal. Note to myself, the AC wires, one goes here and the other one, the other yellow one, goes there. So the next step I need to take in restoring the tuner amplifier, the Saba, is I need to fix the lighting of the instrument panel, right? So the meter here, the strength, the field strength meter, the indicators for FM, stereo and AM, and then the lighting of the dial panel right here. Now, originally the whole panel front was lit with very small AC filament bulbs, you know. Pretty much like little panel indicator light bulbs they use in cars, right? And these were stuck into little fittings like these. Okay, 6 of them in fact. So 1, 2, then there are 3 here, 1, 2, 3, and then there's one inside the field strength meter, or the, you could say, the reception meter. Yeah. Why they didn't place a light bulb in the center fitting right here, I don't know. But I think I'm going to give it a try and install a 7th light source here. And then when I say light source, I'm going to use LEDs to do that, right? So as you know, I have I love blue LEDs, right? So like the panel meter on my Variac is blue, you know. Wherever I can, I install blue LEDs. So my goal is to install blue LEDs for the dial panel, and then a blue one for FM, a green one for AM, and then a red one for the stereo indicator, and then again a blue one for the meter. At least that's my goal. Now, like I said originally, the light bulbs were fed by AC. You know, this green and black wire go to the transformer directly, so there's no rectifying being done. It's pure AC, and it's rated, if I'm not mistaken, at 6.5 volts somewhere, you know. So I need to make a little let's say a little DC regulation or rectification circuit to feed the LEDs that I'm going to mount. Now, don't worry, for the purists among you, I'm not going to make any big changes to the tuner amplifier, okay? If I do make changes, I always try to make them completely reversible, and at least easily reversible. So no, I'm not going to extensively modify the tuner amplifier. One side note, I also replaced the electrolytics on these cards here. So there's one card here, and I think this card is the FM stereo decoding card. And then there's this little card here, which I have to be honest with you, I don't know at this moment what this card does. But these two cards can be removed, so they can simply be unplugged. Yeah. There's just a little, for this one there's a little plastic hook you need to undo from the bottom, and then this one has a copper hook here which you can just pull loose like this, and then you can pull up the card, right? Alright, I'm still working on a solution to replace the original light bulbs for the panel lighting. And I have a whole bunch of these panel mounts for LEDs, 5mm LEDs. So something like this, right? And they come with a little cup through which the leads of the LED fit. Now, instead of using it the way these panel mounts are meant to be used, I reverse them like this. See? And the little plastic cup is at the bottom, as it should be, See down there? Yeah, and I mounted the LED with some transparent heat shrink like this. Alright. So as it is here, yeah, it's practically usable. Yeah, it's still a bit loose, but I think I can fix that. But look at this. See? It fits really nicely into the original light bulb's spot, right? So the only thing I need to fix now is it's still a little bit loose, but I think I found a solution for that. Alright, and that is the final solution I'm going to go for. I tried to make it fit snugly by wrapping yet another layer of heat shrink around, let's say, the base of the panel mount, but the heat shrink turned out to be too thick, but only by a hair or so. Now I found a final solution, which is the LED is a point source of light, meaning that it shines at its brightest from straight ahead, yeah. But a filament light bulb doesn't shine straight ahead, it shines all around, yeah. And you don't want a point light source shining on the plastic bezel of the front panel, yeah, because if you do, you're going to see a single beam of light instead of diffused light all around. Now to that I found a solution, namely I have very thin plastic. Let me show you. I have very thin transparent plastic, or I should say translucent plastic, like this. And this plastic is extremely thin, really thin. So by using this as a cover for the LED, I kill two birds with one stone. I make it fit really snugly in place of the original light bulb, and I have a light diffuser as well. Alright, this is the little power supply I built for the LEDs, and it's built around an LM317. Alright, this is a very classic power regulator chip, and it's rated, if I'm not mistaken, to up to 1.5 amp. But we're never going to need that. If my calculations are correct, it will have to source, I'd say about 140 milliamps. So I don't think the LM will ever get very warm. And there is the little rectifier bridge, yeah. That one, it's a DB107. That one is rated at 1 amp maximum. Again, more than enough to supply voltage for the LEDs. Then a filter cap and then a trimmer to set the output voltage of the power regulator. And then a small surface mount connector so that if anybody in the future would have to work on the print board, can simply disconnect it and then work on it like that. To cap it all off, I'm going to put a layer of heat resistant Kapton tape, yeah, over the bottom of the PCB, because I want to make sure that none of these wires ever make contact with the heatsink to which I'm going to mount the PCB. Yeah, This is a nylon strut here, and it will be mounted to this, but this is aluminum, and obviously you don't want any of the traces on my little power supply to get shorted by the aluminum of the heatsink. Okay, so yeah, you might ask, but why fix it there? Well, first of all, because the heatsink already had a hole there, so which I could use, and second of all, it's still close enough to the transformer so that I don't have to wire it all up somewhere else in the tuner section, because yeah, you want to keep AC out of the tuner section, right? So there you go. And oh yeah, the heatsink, this one here, will also function as an shield, you know, so to minimize the amount of hum that might be introduced into the amplifier section. These are the specs I used for the LEDs on the front panel. Well, mainly the ones for the FM, the stereo and the AM indicator. Alright. And the lower half is a simple schematic of the voltage regulator I built around an LM317. Alright. To regulate the voltage to the LEDs which light the tuning dial and the reception strength meter. Yeah, so in effect it's that little thing there. Alright, so that's exactly what I built. Alright, so yeah, there you go. And these are the wires that run to the transformer and to the power amplifier, to the amplifier. Yeah. Alright, so this is the bottom of the tuner amplifier, and there are two details that I wanted to show you. Mainly the main fuse, which is right here, right there. Alright, and it's rated at 630 milliamperes. Okay. And then the other thing I wanted to show you was the fact that the masonite bottom, which protects the main PCB inside, is held by just one screw, that little screw there. So if you unscrew that little screw here, you can slide the whole masonite backing to the right, and then you can just pull it out like this, and it's that simple to get to the main PCB. And these are all the parts that I replaced inside the tuner amplifier. Right. Quite a bit of electrolytics, and a few light bulbs, and a few wires, a knob, etc. So quite a few parts. But now at least the whole thing is up to date. Alright, I'm going to run through the FM band, and I'm not going to linger on any particular radio station for obvious copyright reasons, but I'm going to scan through it just to give you an idea sound wise how the Saba sounds like when it's on. So here we go. Alright, now let's switch over to AM band. Now I have to say the AM band in my country is not worth very much. At night sometimes you can pick up a few transmitters abroad, you know, England, Germany, Ireland, sometimes even Hungary, but that's about it. But let's give it a try, right?
Going to be buying a new squad class when we come up, but they are young lads, and if you look at the stats, we've done the least running in the Premier League, and not even not working out, that's just covered ground covered in games. Our players don't need to, they're really well organised, so possible that.
All included May and June 2025 की bookings जल्द हो रही है. To book your seat, visit asiangeographical.com or call 0208 353.
Alright, Alright, so that's about it on the AM band, unfortunately. Like I said, reception on the AM band is pretty bad over here, unless you use a big antenna, yeah, and then you can do what some people call DXing, so reception from afar. Alright, so back on the FM band. Alright, so there you go. That's a quick overlook of, or quick scanning in fact, of the radio band. Now let me give you a final overlook of the front panel of the Saba, and then we'll close it up and we'll consider it as finished. Alright, as probably some of you know, the Saba is I would say, typical German product, and this is what I would call an iconic 70s Saba tuner amplifier. Saba was always considered as a bit high-end, hi-fi stereo equipment, and they certainly did their best to give it a finish and a look which fit the contemporary fashion statements back then. You know, this is a really a typical 70s tuner amplifier. All right, the looks fit the bill completely. So as is fitting for a 70s appliance like this tuner amplifier, it has sliding potentiometers, okay, for the volume, which in German is written as Lautstärke. Okay, see it here, Lautstärke. Then you have a potentiometer, slider potentiometer for the low sounds, Tiefen, for the high sounds, Höhen, okay. Then you have a balance potentiometer here, which is written balance in German as well. Then you have a DIN connector for headphones here, alright. The on-off button, Ein, Aus. And then you have a feature which you will rarely see on amplifiers, which is this, okay. Since this is supposed to be a quadraphonic amplifier, meaning that you could have two speakers in front and two at the back, you could switch on and off the speakers as you wished by using these switches here. Now, default, the front speakers are always on, right? Default. But you can switch them off with one of these buttons, in fact this one, okay? The back speakers, which were supposed to be quadraphonic, could be switched on and off with this button. Yeah. I don't have 4 speakers, so I couldn't test it out. But it is my impression that this is not really true quadraphonic. It's more like twice stereo. Yeah. But I can't be certain. The service manual mentions very, very little of the quadraphonic option. So I'm guessing because this model of amplifier was built in the late 70s, right? When people had more or less decided not to go ahead with quadraphonic transmission. Alright, then you have what they call linear. This is a filter which allows you to filter certain sounds differently from what you can set with the high and low settings of the volume, in fact, well, of the sliders here. Yeah, so this filters the sound differently. I tried it out. What it does mainly is cut back on the bass sounds and amplify slightly the higher end of the frequency band. Yeah. So let's say it gives a more quote-unquote realistic sound. Yeah, if you use this. Then this is the mono switch. You press this if you want to hear sound in mono, either from the tuner or from another source. You can connect a tape recorder or a record player to the amplifier, and then pressing this button will allow you to play either source in mono. But my guess is probably no one will ever use this option, in my opinion. Then you have a selector to select the input source as a tape recorder, which is called Band in German. Then phono is obviously the record player, so you press this one to select the record player. And then you have the 4 band switches, alright, and U stands for UKW, which is ultra kurze Welle, so ultra short wave. L is for long wave, lange Welle. M is for AM or medium wave, so medium Welle, yeah, or Mittelwelle. And then K is for short frequency, short band, kurze Welle, okay? And then one of the nicer features of the Saba are these preset buttons, yeah? These allow you to preset a few stations, and by turning this little black sleeve clockwise or counterclockwise, and then by pressing the button you can switch from station to station. Yeah, you have 5 presets. This is simply to select manual tuning rather than having the presets. Now there is this interesting little switch here, so if I turn this clockwise, you see, this means automatic tuning. So if you can't pull in a radio station on the FM band quite right by manual tuning, you just switch on the automatic tuning, and the radio will do it for you, and it works quite well actually. It snaps immediately towards the station. I tried it out and it works absolutely great. So there you go. And then of course we have the signal strength meter over here, and the tuning knob, right? Now the tuning knob, the original one, was a really ugly plastic, cheap looking knob. I can show it to you. So this is what the old tuning knob looked like. Okay, so just a cheap plasticky, very lightweight, ugly knob, yeah, which sort of you could say is a bit out of tune with the fact that Saba tried to give the whole tuner amplifier a bit of a more sophisticated and less cheaper look, right? So rather than go for the original tuning knob, I went for a massive aluminum black coated tuning knob. This one, in fact, and it did cost me a bit some money. Yeah, it wasn't very cheap, but it looks great on the amplifier. Alright, another detail that really bothers me a bit. I noticed that you know, this front, the whole front is black plastic. Now let me tell you, black plastic is the pits. If you want to clean it, you can clean it, but it shows every little imperfection, every speck of dirt, you know, and black plastic is really a pain to clean, you know. But you know, that's the color scheme they went for. They went for black front with chrome elements and a white case. So very contrasty. Otherwise, that's about it. I mean, I like it very much. It's a design that I love. I love 70s design, and it looks great now that it's finished and updated, you know. And there you go. And this is what it looks like with the lighting, you know, of the dial front, the tuning dial, and the signal strength meter and the indicators. I love it, and it makes it a bit more, let's say, up to date, contemporary, right? So, and then have a look inside here, and there you see the LEDs. Alright, so the LEDs in fact shine into very thick perspex plastic, which is then reflected by a 45-degree angle bevel, and the light is piped down into the perspex fronts, the perspex front, right? So there you go. I tried to minimize the banding of light by covering up, or rather by spreading the light, as it were, of each LED. I succeeded, but not quite. But I mean, the effect is not too, it doesn't really disturb me. So it looks okay. And then the same thing for the signal strength meter. I tried to dampen the light a little bit, and now it looks great actually. So I like it very much. Yeah, there you go. So, and it functions really well. You see? So, and if I mistune a little bit and I switch on the automatic, you see, it pulls in automatically the station. So there you go.